YouTube, and welcome to the potentially last part of this series where we implement a toon shader that renders by using a deferred renderer and some shadow mapping. I've paused the simulation stuff because I wanted to play around with the settings for the shadow map. I've committed the recent changes. The resources that we use for this episode here is linked down in the description down below. I think I'll strip it out of the final repo so that the artists themselves only get referenced on these videos here, but you would have to visit their itch.io profiles to actually get the resources. I don't think they should be on a GitHub repo. So yeah. Anyway, so during the last episode, we implemented the shadow mapping calculation here. Since this is a deferred renderer, we only need to do some stuff here in our pixel shader, and then we actually have something that we can output to the what do you call it? Yeah, output to the screen. Okay, so in order to do outline, what do you call it? Outline detection and coloring. We will use our G buffer here. Remember, that's the output of our deferred shader, where we have these three resources here. We have the position, we have the normals, we have the diffuse color. So these are our three buffers with our information, and also we actually have a depth buffer as well. So let's see, G buffer, depth buffer. So we have this as well. Let's see. Yeah, so yeah, so that's basically the information that we want to work with. We're gonna do a what do you call it? We need to do some sampling. Of our information here. And let's just try it out. So let's see. Let's do a function that kind of like returns an outline color. Outline color, outline, I guess. Let's try building something like that. And we should get a float2 UV coordinate. And let's do, we should actually have something like, yeah, we should have a value. So let's implement two parameters in our root signature. Let's do two root parameters, which are our screen size. Let's see, constants. Num2. And let's see, root parameter for constant. Let's see, what's our options, descriptor. Let's see. Register space. Let's see. We have register space 0 for our primary constant buffers. So let's see. Root parameter for constants. Shader register 0. So let's try building something like that, and of course expand our parameter size here, and of course include it in the root signature itself. So let's hide our samplers here and add this. Let's see. Okay. Error serializing the root signature. Oh, 1, 2, 3, 4, 5. Huh. Do I need something else? Yeah. Let me just see. I'll just check what I usually do for these parameters here. Usually they don't make a whole lot of fuss. Oh, I still need to set the parameter type, of course. Let's see, parameter type. There we go. So this is the issue. Yeah. So now we have two 32-bit, what do you call it, parameters here. And let's see, we will have a series of constant buffer root constants here. So struct root constants constants. And let's do unsigned int width and unsigned int height. And I'll show you in just a moment why this is important. So let's do constant buffer root constants. Can I just do that? Oh no, that's the struct. Constant buffer root constants. Huh? Excuse me. G root constants, and then register B0s S1. Is this not? Yeah. Okay. And let's just return one here. And inside our shader, we will calculate a texel value. Texel texels, which will be equal to 1 divided by float 2. And we will take our G root constants width and our G root constants height, because we would want to know how to map into our screen textures here. And remember that for each pixel on the screen, we actually have a piece of data. And let's say that we want 4 samples here. Samples, which we are going to create like the first one is going to be UV coordinates plus texels. I'd say at least. The other is UV coordinates minus texels. And then we want UV coordinates. So this will check on either side of the texel, and then we will. So with the positive one, we will be offsetting down here, I mean, and minusing, we will be offsetting opposite. And then we of course need the other 4 corners. This is just one way of sampling. So let's say that we want plus texels x, and then minus texels y, and then UV coordinates plus minus texels x, and plus texels y here. This is our samples. Whoops, not like this. And we don't need the one there. And this is what we do. And let's do an array because we're gonna sample our depth, our normals, and we could do the albedo sampling as well, but let's just start out with doing our normals and depth values and see what we end up with. So let's do some depth samples here. We will do 4 because we have defined 4 samples. We will do normal samples, which will be a series of float 3s, normal samples, also 4. And then we will actually sample. So for in I equals 0, I less than 4, and then I plus plus. And we could unroll this. All right, I plus plus, of course. And then let's do some depth samples. I equals, let's sample our texture with our depth. And let's see, let's minimize this. So we have our depth buffer here. And maybe let's do linear sampling. So depth buffer, G depth buffer. And let's sample it with our G samp. What did we call a sampler? S linear clamp, and we will use our samples I. And this is going to be the R value because, yeah, we don't want anything else. And let's sample our normals as well. Normal samples here, I, just the same way, normal, buffer, sample. And let's see, let's sample again. Nah, let's do point actually. Yes, point clamp here. Let's just try that. And there we go. Dot rg xyz here. And that'll be it. And let's take our corners of our sample here. This is basically kerneling, and what we're going to do is calculate the difference between the two corners to see if we actually have an edge. So let's see, depth diff 0, and let's do depth samples 1 minus depth samples 0. And we will do a depth something. Depth samples here. Let's do 3 minus depth samples 2. And let's get a depth edge value. And we could, for instance, do a square root here of our two values squared. So let's do depth diff plus depth diff 1 times depth diff 1 here. And then we could do a threshold, depth threshold equals some kind of value here. Maybe we should create a parameter. Depth, let's see, const depth threshold. Float, of course. And let's do depth h value equals to whether this is above the threshold or not. If it is, we will do 1, otherwise we will do 0. There we go. Let's just parenthesize this so it's more clear. And let's do the same thing for our normals. Let's do float 3, normal diff 0, and we will do normal samples 1 minus normal samples 0. And let's do the same thing here. There we go. And let's do float normal edge value, and let's do a square root of a dot normal diff plus dot normal diff 1 normal diff 1. And then again we want a normal threshold and this will be equal to normal threshold, and it will be 1, otherwise it will be 0. Oops. Okay. And let's calculate an edge, which is just the max of the depth edge value and the normal edge value. And let's return it. Okay. So right now let's reduce the complexity a bit here, and let's just do intensity times albedo here as our color. And let's see. Oops, of course. There we go. Whoops. B0. Is it wrong? Let's see, space. Do I have to be verbose here? I guess I have to. Line. let's see. 80. Do I need to? Which one is the warning? It's right now treated as an error. Common expression used where a vector constructor may have been intended. Yeah, okay. I see. Yeah, it got too implicit here. There we go. Okay. So right now we have disabled the shadow stuff. All right. So let's try to get an outline value. And let's say that float edge equals outline here, and let's do our input.uvs. And let's do maybe 0.5f here and 0.5f here. I don't know how the scale is. Times edge value just here, just for fun. Whoops. Yeah, we need to bind the value, of course, otherwise we will have a division by 0. So let's see. In this part, no, down when we do the draw call itself. Yeah, this is the final draw call. Let's do command list, gfx, command, set, root, 32-bit constants. Let's do, this is 4 and 2. And then we will create an array here, unsigned int array size. Let's do, what's our width and height? Do we have that value anywhere? Is it in our application? I'm unsure. Let's see, main application, engine app. Okay, they are here. And let's do size here as our reference and then 0. And this should fix our issue, right? No. Root signature doesn't match pixel shader. Shader sampler descriptor range. Did I mess this up or? Let's see if I comment this one out. Well, no, then I'll get into trouble. We have 3 samplers. Oh, we of course no root signature has been set, so setting. Okay. It doesn't think that the root signature got set or what? Huh. I'm pretty sure it's set. Well. Okay. Our pixel shader here. Let's not do that right now, and let's see. So we're still running. Let's just hard code this for now. Duplicate this. 1240, 700. Is that the right one? I'm not sure. No, these are the values. Let me just hard code them for now, since I'm not gonna bother with that. Okay. And let's see. Not like this. Edge. Oh, there we go. So we actually do get some data here. As you can see, we definitely do draw some outlines. So let's do something like if edge. Let's do a color equals then a float 4, 0, 0, 0, 0, and 1. Else we do the albedo here. Whoops. Okay. Okay, we're starting to look more toony, right? That's pretty neat. That's pretty neat. So we definitely need some adjustments here. Because our edge is getting pretty big. Also, I'm not sure if the threshold is too small or too big. Let's see. This makes our threshold even bigger. Let's try something that is a bit more. Yeah, okay. This doesn't affect our actual width of our thingy here, I think. But let me just check. It might actually be shadowing things a bit more. Okay. Now that's pretty interesting. We definitely got some some more detail, right? I mean, if we do like this and disable it, it's definitely more cool with the edge detection here. Yeah, and you can do different, what do you call it? Ways of actually sampling the whole the mesh data. I mean, it's a bit heavy, isn't it? Let's see. I mean, this is somewhat thick, right? Um, let's try something very big here. Okay, that's way better. But now it kind of like misses this, uh, what do you call it? Edge over here. So, uh, we could do more fine-grained sampling. Maybe um, the pixel itself is not high enough resolution to actually catch this stuff here. But it seems like we get more edges the lower we go. It's like sort of an edge thickness or something of the likes. But this object here doesn't seem like it has any, what do you call it? Yeah. Okay. Let's do something like smooth step. Minimum and maximum. Minimum 0. Maximum is 1. And let's do intensity here. Let's do factor here. Let's do factor instead. Whoops. Unexpected token smooth step. Oh. Okay. So things are coming sort of to life, right? This is definitely looking more toony than before. Okay, let's play around with the shader stuff here. Of course, we reduce the threshold and we start to see a bit of an outline on this one. Okay. But we could, of course, also separate rather through color. And maybe we want something that scales relatively to the data itself. So let's play around with the okay. So let's do a normal threshold, which we will compute by dividing, changing this to a sensitivity. Normal sensitivity. There we go. And let's normalize this also as a depth sensitivity. Let's do float depth threshold. And let's just do one of our values to kind of like normalize it. Let's see. So we have these sensitivities. So if we lower them, we should see a lesser effect. I really like the way the skeleton gets highlighted in the face area. All right. So we don't really capture the what do you call it? Differences in plus shadow factor times albedo here. Divided by 2. Let's do that. All right, that immediately looks way more stylized, right? That's pretty cool. We could also do sharper shadows by actually kind of like smooth stepping them a bit, I guess. Oh, they're not really that smooth, so I guess it works. Anyway, we're still not really capturing any outlines on this object here, and I'm not sure why. Let me just port these shaders into render dock territory. I almost said, let's see, let's move these shaders. And let's open the application here in render dock. So in terms of, let's see, position, we don't have much difference, so that wouldn't be as interesting. Let's see. For our normals here, that we even, I mean, can't I swap it? Okay, so we actually do have some data here on the normals. I guess the vertex normals aren't. The object is somewhat smooth, right? So maybe the normals don't change that much. But I mean, this difference here, I think it should be finding something. Okay, let's try really reducing the normal sensitivity and just doing the depth stuff. And let's increase the depth sensitivity very high. Nothing is really happening, huh? Now we start seeing some edges here. Okay. Way more. Okay, so we really need a large value here, it seems. And immediately we start to see these cross lines here where the depth itself kind of changes. Yeah. Okay. Interesting. And we of course shouldn't draw lines a lot of weird places. But this is starting to get a bit better, right? Yeah, it immediately gets some more detail, which is pretty interesting. I mean, if we only do the depth thingy here. Okay, immediately we start seeing smearing when we go that high. So, yeah. And this is of course either or, meaning that if the depth doesn't catch anything, well then the normal stuff won't either, or rather, they won't be captured at the same time. That's what I meant. So let's see, 1.5 perhaps. Yeah, okay, that's way too much. Now this is looking pretty stylized, right? And maybe if we did some color comparisons as well. Okay, so let's try that. So we have our normal stuff. We have, yeah, we actually could like make this more efficient by not testing the normal and the albedo twice, because we always, well, I guess we always add the texels. Yeah, this is kind of like doing 4 samples around the actual pixel. But you could do Sobel sampling instead. Also, what happens if I do point clamp here? If we change this sampling method. Okay. Let's just screenshot it. And then do the linear clamp again. And let's try to compare them. Do we see any major difference? Actually, I don't know if it's just me, but I think I see a bit less smearing on the point clamp, but it's of course way faster. Okay, let's use the point one. Okay, and let's do a these values here will always be normalized since we're dividing them into one. Well, I guess not the depth stuff here. Yeah, I don't think we should use this. Let's just do a normalized version. At least for now. And then let's try doing some color samples. Or rather, let's call it albedo samples. Since it's what we actually sample. And let's do albedo buffer sample with a S point clamp here with our samples. And we only want the XYZ because we don't want the alpha, red, green, blue. All right, and let's do a calculation exactly like this, except we albedo diff. And let's do albedo samples here. And color edge value, color threshold, color sensitivity, and let's add that const flow color sensitivity, and let's do color edge value, about the threshold, and let's do another max here, color edge value. Okay. Let's do a threshold here by doing a low one for starters. And let's do a lot. Shouldn't this give us a threshold right here? Or are we not? Maybe we're not sampling fine enough. I don't know. Maybe we're missing something here. 0 threshold. It's sensitivity rather. It's very low. Whoops. And let's see. Okay, let's set this to 0 or rather very low. And let's set this to something big, I guess. It doesn't really affect anything, does it? I mean, the color should change. Am I? Albedo diff, albedo diff. Am I sampling the... Yeah. So what's the problem, Mr. Officer? Albedo samples. Ah. Let's just do something very, 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 very big. It still doesn't really detect any edges. Now that's interesting. That's pretty interesting. So something's wrong with this method here. Somewhere in the code. We're doing the albedo samples. XYZ doesn't matter, right? No. So albedo buffer. It should be bound because we're actually sampling color in other parts of the shader. Color edge value. Huh. Let's do something. Hmm. Okay. For some reason it doesn't do any difference, I guess, with the actual stuff. Let's see. maybe 100 here. And this should be way lower. Maybe not that low, but maybe, I don't know. Is it supposed to be a bit lower actually? Color sensitivity. Yeah, the depth one is really interesting because it seems like it has a somewhat high value, but it starts smearing sometimes. Yeah, you could definitely play around with different algorithms. Okay, I would suggest implementing a Sobel test instead, or rather Sobel sampling instead. Yeah, we could do that. In a different episode, I think, because yeah. Also, we could try adding a factor here to our what do you call it? Texel stuff. Yeah, you should definitely play around with the sampling here. Yeah, I'm not sure I like this way of sampling. Could implement Sobel edge detection instead. You know, like this kernel, like the here. I think it's -1, -2, -1, and then 0, 0, 0, and then 1, 2, 1 for the horizontal one, and then of course, can't remember if it's minus, or is it if it's the other way around, but applying a kernel like this to each of the pixels, and then or rather this should be the pixels, right? So 9 samples horizontally, 9 samples vertically for each pixel, and then you kind of like get a threshold value with a now there's an edge. You can also do another derivative of that and figure out what the slope or change in intensity is. Yeah, I mean, it's not totally bad. Also, Let's do 1, 1 here. Whoops. 0.99. Can I do that? Actually. Yeah, so that gives us a totally flat color. Which is actually pretty cool here with the, what do you call it? Let's just set this set. Let's test the shadow factor as a 1. Yeah, everything gets flat. And if we change the smooth step here, maybe we don't want smooth step, maybe we just want step. Whoops, that's not the correct code then. Whoops, let's do this. Step. Yeah, maybe this is what we want actually. It gives this kind of like smooth shading here, but I'm not sure we want it. Maybe we want a more defined shade. Load factor, step. Now this gives us a very, very cel-shaded look, right? That's pretty cool. And then let's add the shadow mapping stuff again. Yeah, now that looks pretty interesting, right? Because then the object is self-shadowing. I mean, no, that's not actually self-shadowing. That's just cel-shading. That's pretty cool. That's pretty cool. Okay, so let's re-add the shadows. Yeah, so this one seems like to be a shadow map shadow. So the cel shading stuff really gives the impression that, yeah, it's really cartoony. And let's see, transform text, floor, desk. Let's raise it up just a tiny bit here and see if we actually get an edge. Yeah, we do get an edge. So it's because the normals are actually clipped away. So it works, the outline stuff works way better when we can actually see the foot of the actual object. Yeah, should sync it a bit more. That's too low. Is it still clipping into the floor? Yeah, that seems like we're getting sort of an edge. Yeah, definitely getting an edge now. Okay, pretty interesting. Pretty interesting. So that's most of our tool shader done here. And you could, of course, manipulate the width. Of the kernel itself. Width and height, of course, but you know what I mean. We do get more details when we do the depth stuff there. Right. And this is probably just double outlining or something. I just realized there's a spelling error in the Blender text, right? Isn't there? Oh my god. Okay. Let's see. Add text in edit mode. DirectX12 tutorial. And let's rotate it by 90 degrees on the C-axis. No, not C-axis, on the X-axis. Edit mode. Tutorial. I can't spell. Oh my god. Let's see. No, that's pretty funny. If you can't spell like me, don't worry. Yeah, okay. And let's uh, convert to, let's say, extruded first. Edit mode. No. Object mode. Can I do, is it bevel depth, no. Where's the extrude one? Anyway, I'll mess around with that off stream. Just have a laugh when you realize that I totally spelled tutorial wrong. At least it's not a spelling tutorial. Anyway, I hope you found it helpful, entertaining, or inspirational. As you can see, we're actually um, doing edge detection here by using our depth and normal values from the G buffer, and this gives our scene a stylized look. So you can definitely play around with different Toon shader stuff. I think this turned out pretty good. And if you like this series or would want me to do an extension where we, for instance, implement some GUI stuff or other interesting topics, feel free to comment, like, or subscribe, and let me know that you want a continuation. Anyway, thanks for tuning in and watching. Hopefully I'll be seeing you around. Also feel free to join the live streams here on the channel where I do my game project. All right, take care everyone. See you around. Bye bye.